So welcome everyone, and thank you for watching this first Dev to Dev video by Bitnami and GitLab. So my name is Javier Salmeron, Salme, people call me, and I work as a member of technical staff from Bitnami, where we package more than 130 applications for different platforms such as the cloud, installers, containers, and in this case for the VMware marketplace, where we have standard or collect recently or catalog with several applications, and one of them is GitLab Enterprise. We've had GitLab Community Edition for a long time, and now we are proud to have in our catalog the Enterprise Edition of GitLab. And here, so this application you can deploy it in either GitLab Director, you can deploy it in VMC, in AWS. So we're here today with Colin Taylor from GitLab, who's going to show us how the cool things that you can do with GitLab Enterprise and different features that he has. So he's going to show us some interesting things for you to use in GitLab.
Yep.
So thank you for coming, Colin.
Absolutely. Thanks a bunch for having me.
Right. That's perfect. Let's see. I can't wait to see what you have to show us. So, but first, if we want to see GitLab Enterprise, we have to deploy it. So the first thing that I'm going to do is show you the VMware marketplace, where you can choose the GitLab Enterprise Edition and have it deployed in your cluster. So let me share my screen, and let's take a look. So here you can see the VMware Cloud Marketplace, and you can see that we have the whole catalog of Bitnami applications available. See more than 130, around 190 applications you can see in the products. And we're going to look for the GitLab Enterprise Edition. So I'm going to just search for GitLab, and you can see here the GitLab Enterprise Virtual Appliance. So the first thing that you need to do in order to have it ready in your cluster is you have to subscribe to this solution. So make sure you have an account with everything configured in VMware with your data center configured. And with that, you're able to just click on subscribe. You have to go through a wizard of different things. And essentially the most important part that you need to take into account is first where you want to deploy it. So you can deploy in VMC, vCloud Director. So let's go for VMC that I have configured in my account. And with that, the next thing you have to do is select your data center. My case is the marketplace test data center. And you have to input the credentials of your data center variable. So right now I've just put my credentials for my data center. So now I can click on next. Then you will get more information about where you want to deploy it, in which data store. In this case, I only have one. And after this summary and reading the agreement, once you take a look, I don't have the time to read it right now, but you accept, then you're ready to go. So in my case, it was already subscribed. In your case, you will see that subscription success message. And with that, now that you have subscribed to GitLab, you just can go to your data center and have it deployed. So let me just go to my vSphere data center, and you have to go to the content library section that you have here. So here you can see they have different sections. You have to go to VMware Cloud Marketplace and then go to templates. And there you will see I have several here for my different tests, but you can see here my GitLab Enterprise Edition 12.2.5, which we just described. So you just have to click on that and go to Actions. And let me just move this. And then just launch a new VM from this template. So you have to first select where you want to deploy it. In my case, I only have one data center. I will put just GitLab demo test. You can see what it is. And once we have this, we just go to next. We want, once again, we select which cluster in the data center that we're going to use. Get some validation in place. It tells me what's going to download, which template is going to download with virtual image. We accept the agreements once again. We select the storage again inside the data center. In this case, I'm going for this second one. And then I need to also select the network. In my case, I have different networks. I just go for the Bitnami network, which is one internal that we use for testing. You can choose whatever fits your needs in your cluster. And then you have to, if you want to connect using SSH, you have the option to introduce your public key here. So in my case, I'm going to do that. I'm going to just copy and paste my public key. And I'm going to just paste it here. And with that, we're ready to deploy. So with these details, and it will just start deploying. Well, for the sake of this recording, we already have one deployed, which is in this section, in the VMs that I have deployed. I already have one running, which is called GitLab EE test. So this is what you expected to see. You'll see that the VM is running. You can enter the web console. You can check any details to see if it's running. And if you SSH the instance, for example, using your SSH client or entering the web console, you can just open the Bitnami credentials file in the home folder, which will show you, just as you can see here, the credentials to access the instance. In this case, you will see that the username is root and a random password. So with that, you're able to enter the instance, which in my case, I already configured it using a public address, was GitLab EE test nami run. And you can see here the login screen, everything already configured, everything ready out of the box to just put your credentials that you've seen before, just a minute before. Okay, so I put my credentials and I'm able to log in my GitLab workspace, in my GitLab installation that we just deployed. Yep. And with that, now that we have a GitLab running, I would like to see what Colin has to show us. So tell me what you're going to show us today. Let me just stop the sharing so you can take the control.
Yeah, and I will. Also, there was a secret. There was, I think, your data center secret that you'll probably want to cut out as well whenever you grab that, just so you know.
Perfect.
Cool. Let me share my screen. And we're good?
Okay, perfect. We can see.
All right. Do you see it?
Yes.
Cool. All right. We could start from here then. So thanks a lot, Salome, for that wonderful introduction and for showing us how to get a GitLab instance up and running super easy with Bitnami and the VMware Cloud Marketplace. That's something that has been really near and dear to my heart. So I'm glad I got to kind of see it in action as well. So here is what we'll talk about today. First of all, I'm Colin Taylor. I work for GitLab. I do technical marketing. I focus mainly on cloud native technical marketing, which really involves Kubernetes and similar. But I also have a background as an engineer on OpenStack, and then I was a developer advocate for IBM's Kubernetes service for a couple of years as well. So this is kind of right in my wheelhouse. And if anyone out there wants to get a hold of me, just send me an email at ctaylor@gitlab.com, and I'd be happy to talk with you. And if you want to know more about GitLab, you can go to about.gitlab.com. So real quick, what we'll cover is we've already kind of done the first two bullet points, but we'll go ahead and add a GitLab Ultimate license to that instance that was brought up. We'll add a Kubernetes cluster to that instance. We'll do some installation of some really helpful applications like the GitLab runner, which will run all of our CI and some other stuff as well. And then we'll add a project to our instance, and we'll trigger a pretty opinionated, but nevertheless fully featured CICD pipeline with a feature we have called Auto DevOps, and that will show off some of our more enterprise focused or paid features with the license. So real quick, a lot of people think of us as just an SCM system, or maybe an SCM system with CI built in, but really we really do all of these things. We don't just store your repos. We don't just run CI. We also have all kinds of project management tools. We have static application security testing. We have dynamic application security testing. We have release tools, and much more. Basically, what we try to do is to present ourselves as a full tool chain for the entire DevOps lifecycle, or the entire software development lifecycle as we know it today. And we're rapidly approaching, actually achieving that goal. And in some sense, we already have, but basically, the only parts of this tool chain that are really kind of lovable right now are the SCM part, the CI part, and I think some of the release tools are really great as well. But everything else in our stack continues to improve day by day.
So let me see if I understand. So you're saying that with GitLab, I can just cover all of these elements of life cycle, you say, right?
Correct. So you might be used to managing one or many of these tools, in a given development environment. And GitLab is meant to replace all of these tools and deliver all of it as a single application with a single UI. That way you aren't having to jump around between 10 different browser tabs that all have different UIs and doing a whole bunch of different things.
Yeah, I totally confess that when I think about GitLab at first, I always thought about more like a storage or repo. So it's kind of impressive just what you can see, everything that it actually covers. So
yep.
Impressive.
Yeah, it's some really cool stuff. That's before I started working here. Kind of whenever I was looking around, I looked at GitLab because I hadn't checked in a few years, and I was like, wow, they're really doing a lot, and here I am. So let's see. Yeah, a lot of this is like marketing stuff. We'll talk about Auto DevOps. I'll show you it. But basically, we aim to have a GitLab installation, a Kubernetes cluster, and if you have those two things, then you can get up and running with a full CI/CD pipeline really easily. We provide templates out of the box, and of course, you can configure it yourself, but that is a much longer and deeper video, which maybe we'll do in the future. So today, we'll go the easy route. And then this is kind of how we gate our features. We have 3 levels of license, and we also deliver the same features on GitLab.com, which is our kind of like SaaS offering. But today we're worried about self-managed. So I think with that, we should just kind of jump into it.
Yeah.
Cool. Let me get to the UI. So I need to move this thing. There we go. So I've maximized my browser window just to make everything visible and get rid of some of the extra stuff we don't need. But now that we have our GitLab instance all deployed, we're logged into it, and we get dumped to this kind of starter screen here. And this shows off some cool things that you can start doing once you've gotten your GitLab instance deployed. For instance, you could create a project. You could create a group of projects. Maybe if you have a group of tools that should all live in the same place, you can add some people, or you can do some further configuration of GitLab, which we're about to do. But the first thing that we want to do is add a license. So if you were to click this button right here, it would take you to a web page where you could fill out some information and get a 30-day free trial of GitLab with all the features unlocked. But also, if you are an open source project, we offer licenses to open source projects for free. So if you qualify for that, then definitely drop us a line and we'll help you out. But I'll show you how to add a license here. What we'll do is we'll go to the admin area by clicking on more and going to admin area, kind of like I just did. And over here on the left-hand toolbar, we can go to license. And again, it gives you the options to start a free trial or buy a license, but I already have one, so I'm going to upload a license. You can do it either as plain text or as a file. So I will just do it as a file. Cool. And here we can see that our plan is ultimate, which means we have all the features of GitLab unlocked. We can see when it was uploaded. We can see when the license actually started and when the license expires. You can also see the number of users in your license. So in this case, we have 10. But we also operate on a true-up model. So say if tomorrow you hired 10 more developers and you wanted to go ahead and get them up and running, you wouldn't have to purchase more seats in your license. Just go ahead and sign them up and we'll bill you, retroactively. So now that we have all the features of GitLab unlocked, let's start using some of them. So the main feature that I'm going to show off today is a feature called Auto DevOps, and Auto DevOps is basically some opinionated CICD templates that we provide out there for you. And it allows you to really get up and running and start getting your applications deployed kind of right from the get-go, rather than, iterating too quickly and not implementing, best practices from the get-go, and then having to go and do that stuff retroactively. Like, you can just start having good CI/CD practices from day one. So to activate Auto DevOps, you need a Kubernetes cluster. I'm going to be using a cluster from GKE, but you are totally fine to use a cluster from any cloud provider you choose. We don't really care where your Kubernetes clusters are. We just care that they exist. So I will name it. So you can name it anything you like. I'm going to call this one Bitnami demo. The next thing you need is your API URL. The way you do that, let me increase my terminal font just so you can see. The way you do that is you do a kubectl cluster info. Cool. And the first thing that we get is our Kubernetes master API URL. And the next thing we'll need is a CA certificate and service token. What that means is they correspond to some values created whenever you create a service account in Kubernetes, and a service account just allows you to assign roles to a particular account, giving them different levels of access to your cluster. We require that you provide the service account that you're going to use here a role called cluster admin, which is defined by Kubernetes upstream. And basically what that does is allow the service account to create anything it needs. In this case, our service account will create a GitLab namespace, and it'll create some resources underneath that as well. So let's take a look at our service accounts right now. We have the default service account that will not give us enough permissions. So let's go ahead and create a service account and we will call it GitLab admin. Cool, so it is created and the next thing we need to do is create a cluster role binding. Now what a cluster role binding will do is bind a particular role to a service account that you have in your Kubernetes cluster. So what this will do is create a cluster role binding called GitLab admin CRB. The cluster role that we want is cluster admin. That's that, ultra permissive role that I talked about a second ago. And the service account is in our default namespace since we just created it there. And it's called GitLab admin. And now that we have that created, you can see that it's there. If we describe our cluster role binding, we'll see that it has the role cluster admin and it is bound to the service account GitLab admin. So we're all set up and ready to go. So what we need to do is list our secrets just to get the name of our secret pertaining to our GitLab admin service account. And then from there, we can extract some information from that Kubernetes secret. So we'll get the secret and then we will dump some of the information from it. Okay. Kubernetes secrets are encoded in base 64. So we will need to decode that and then just to make it pretty, we'll add an echo on the end. Oop. What did I miss here? There we go. So we have our CA certificate, and the next thing we need to do is get our service token, which is almost the same command. But instead of getting the CA certificate, we'll get our token. Cool. And the last things down here at the bottom are an RBAC enabled cluster. That's just saying that we have Kubernetes RBAC enabled on our cluster, which has been enabled for the past, I don't know, 3 major versions or so, if not more than that by now. And then we're going to keep the checkbox next to GitLab managed cluster, just allowing us to manage namespaces and service accounts for this cluster. So we'll hit the add button and that will add the cluster. And so the next thing we will need to do is install Tiller into our cluster. Now, you might already have a Tiller pod in your cluster, either in the default namespace or probably more likely in the kube system namespace of your cluster if you've installed Tiller on it previously. And that's totally fine. You can run multiple Tiller pods on the same cluster, especially since the GitLab Tiller pod will run in its own GitLab managed apps namespace. Now we can see, if we check out our Kubernetes namespaces, we can see that we just have the default namespaces allocated to us by GKE. But we're gonna wanna go ahead and create our Tiller pod, which will, as a result, create our GitLab namespace. So let's go ahead and hit the install button. We can see that there is now a GitLab managed apps namespace. If we check out what's in that namespace, we will see that our job to install Tiller has completed and that we have a Tiller pod that looks like it was in container creating state whenever I issued that command, but now it's running. So our Tiller pod is all up and running and it's ready to go, so we can install the rest of the software that we need to get auto DevOps up and going. That'll be, what we'll need to get that going is Ingress. So Ingress is basically the front door for Kubernetes clusters. It installs what's called an Ingress controller. There are many Ingress controllers out there. The one this will install is the Nginx Ingress controller, which is fairly standard. The next thing it'll install is a Kubernetes standard way of provisioning TLS certificates called Cert Manager. And Cert Manager basically just, it's kind of like the Kubernetes version of Certbot. It'll go and broker TLS certificates from Let's Encrypt for you. It's a really great way of getting HTTPS on your application deployments in a really easy way. We'll install Prometheus on this cluster as well, just to get some basic monitoring on there, and then we'll install GitLab Runner, and GitLab Runner will actually execute our CICD jobs on this Kubernetes cluster. That way we have full control over where that stuff runs. You can also install Jupyter Hub if you're into Jupyter Notebooks, or Knative if you're doing serverless on top of Kubernetes, but those are kind of outside of the scope of this demo. So let's go ahead and start installing stuff. And while we do that, I want to just see what's going on as it happens. So if we do a watch on that, we see that we have our Tailor pod, but let's go ahead and install Ingress. Let's install Cert Manager. I will provide my email for the issuer email. That means that that email address is associated with any TLS certificates that your Cert Manager instance provisions. And then we'll install Prometheus and GitLab Runner. And since all of these installations happen in their own pods, it's totally fine to do them concurrently. That's a great thing about Kubernetes. Things can happen all at once, and they're nice and scheduled and well orchestrated. So let's wait for that to finish. Cool. So we have our Ingress controller installed into our cluster. And actually what that does, whenever you install an Ingress controller into your cluster, typically what it'll do is go talk to your cloud provider and provision a load balancer. And once that load balancer is provisioned, the IP of that load balancer acts as your Ingress endpoint, and that will autofill in here. And we will use that as the base domain up here. The base domain is basically just the top level domain, that maybe not the domain that our applications will live under. So all of our application deployments will get, like, say if we deployed MongoDB, it would get like MongoDB.35.188.219.220.nip.io. You can provide an actual real URL here. You would just have to go set up a wildcard DNS record. And instead of doing that for these demo purposes, I'm just going to use nip.io to get me wildcard DNS on an IP. That way we don't have to wait for a DNS propagation or anything like that. So let's save those changes. That's all good to go. Cert Manager is installed. It looks like it's running. Everything's running and good to go. So we are set to go ahead and start doing stuff. Now you'll see here that under this cluster health section, we see some time series graphs for where CPU and memory usage would go. But since we're not doing a whole lot on right now, and Prometheus is also still slurping information from our cluster, they haven't populated yet. So we'll come back and check on that in just a moment. But for now, let's go ahead and start getting a project. So what we'll do is we'll create a project. And from here, we'll do an import project. Now you can import a project, from GitHub, from Bitbucket, from Gitea, pretty much anywhere you store your code. But I like to do it by URL just to make things easy. So the project that I'm going to import is called Spring App. It's just a Spring application. It's basically Hello World. We'll name it Spring App, and we'll make it public. Let's go ahead and grab that. So it'll take a few seconds for our import to complete. All right, now that we have some code in our project, the first thing we'll see is that the auto DevOps pipeline has been enabled and will be used if no alternative CI configuration file is found. Basically what that means is if at the top level of your project you had a file called .gitlab-ci.yaml, defining your CI/CD pipeline, then the auto DevOps pipeline would immediately be turned off. But since that file doesn't exist in this repo, it's going to fall back on the auto DevOps pipeline. So we can actually see right here that a pipeline is actually running. But let's check out the CICD settings real quick. And we can see that we default to the auto DevOps pipeline, and it gives you a deployment strategy. We're just going to do a continuous deployment to production, but you can also do incremental rollouts, and you can do manual deployments to production as well, which is pretty cool. Right here, this is kind of a misnomer. It's telling me that I need a Kubernetes cluster, but I actually already have one at the instance level, because you can add Kubernetes clusters either at the instance level, so that way all projects on your instance will default to that Kubernetes cluster, or you can add Kubernetes clusters at the group level. Say you have a group of projects that you want to share a Kubernetes cluster and have all their application deployments go in there, or you can add it at the project level. Say if you have a private project that has its own Kubernetes cluster, you could connect it up that way. But I did it at the instance level just to make things nice and easy. But it's the same process to hook it up, whether you do it at the instance level or the project level. Like even if we go over here to the operations tab and we go to Kubernetes, we can see that I have the Bitnami demo Kubernetes cluster, and that it's an instance cluster. If it were a group cluster or project cluster, that's what would pop in here. But adding it is exactly the same as it was for adding it at the instance level. So let's go check out our pipeline and see what's going on. Interestingly enough, we have two pipelines. But let's start with the first one, since that one's actually going. Let's actually do this. Let's stop that pipeline just to free up resources. So in our pipeline, we've already completed our build job. So what the build job will actually do is, if we scroll the way up, the build job, if you have a Docker file present for your application in the top level directory of your project, it will use that Docker file to create a container image for your cluster, for your project. But if you don't have a Docker file present, then it will do a Docker build on your project, and it will use Heroku build packs to determine the best way to get that done. So that's actually what happened here. You can see that the login to our GitLab container registry, which ships with GitLab, which we'll talk about in just a second, succeeded. And then it says that it's building a Heroku-based application. If a Docker file was present, it would say building Docker file-based application. So since we built it and pushed it, we can go check out the container registry. And we see that we have a container image here for our application. And we have a tag cut off of the latest Git SHA. And that corresponds to the latest tag. If we were to run the build again and it pushed again, then we would see another, the newer Git SHA pop up, and that would correspond to latest. But let's check out our pipeline again and see where it's at now. So we can see some of these jobs have already completed. So the next thing that happens in the test stage is that we do some code quality scans, we do some container scanning, we do some dependency scanning, we do license management scanning, and we do SAST. So we'll start with code quality. What code quality scans actually do is take a look at your code and make sure that there's not repeated variables or empty lines you don't need, depending on your language, or bad indentation and so on and so forth. It's basically just making sure that your code is readable. and it reports violations into merge requests. So if this were open as a merge request, all that information would actually pop up right in that merge request. So kind of similar to the code quality scans, we have container scanning. What that will do is actually use the Claire container scanner to take a look at our container image that we built. And we could see here that there's actually some CVEs that we're getting, some stuff that really shouldn't be in there. That's expected. This application is meant to be insecure. It's meant to actually show off the capabilities of auto DevOps. So for our purposes, that's a good thing. Typically, you wouldn't want to do that. So we will go back to our pipeline and we'll check out what else is going on. Oops. Boom. Okay. So the next things that are going on, dependency scanning. So it'll scan for dependencies and make sure that the dependencies, like the libraries that your project is pulling in, are not, supremely outdated or known to be malicious or known to be, buggy or cause security vulnerabilities and stuff like that. The license management scans basically, scan all those dependencies and see what licenses they use. You can set a policy in GitLab, say if you don't want to use any GPL3 licensed software for whatever reason, everybody has different business needs and license compliance needs. You can actually set that policy, and if a merge request pulls in a library that is in violation of your license management policy, then that will show up in the merge request as well. Now let's talk about security. We see that we are actually finding all those security vulnerabilities as they're actually getting populated right here in the pipeline screen. All the CVEs that we found with our Claire scanner, so that's very, very good. We see that these are all low severity, pretty simple stuff. There's also, we've got some medium ones. I believe we should have some high level ones as well. No, we just get unknown. Cool. So let's go back to our pipeline and see what's going on now. Oh, and the last job that happens is test. So auto test will use Heroku build packs, much like the build stage will, and it'll actually figure out what is the best testing harness for your language. So for instance, if you had a Python-based application, then it would probably run something, what is that called? Tox. It would run something like Tox, or run some predefined set of unit tests that are out there, and make sure that things are good to go. So in the review stage, what will happen is we'll have to create a review app. What a review app is a deployed version of your application, and a deployed version of your application to a testing environment. That way you can see how it behaves, kind of in a live environment. So this also happens for merge requests. If a contributor opens a merge request against your project, it'll run through this exact same pipeline, and a review app will get deployed to your Kubernetes cluster. So we can see that it actually did the deployment here, and that our application is actually accessible at this address. This has succeeded. Let's refresh this page. Cool. And now we see that we're doing our DAST scanning. So DAST stands for Dynamic Application Security Testing. And what that does is, since the application is actually deployed, it's going to check for vulnerabilities in your running application. So you get a nice 1-2 punch of SAST. checking the actual code, for possible memory leaks or buffer overflows and stuff like that. And then DAS will actually try to implement those. The next thing that happens is we actually deploy to production. So all of our previous checks have passed, and we're going to go ahead and deploy our app, out into the world. And we see that our app is now accessible at this IP. If we do a kubectl get namespace, we should see that our project has its a couple of namespaces, a DAS or review apps namespace. That's basically like a testing environment, and then our production namespace as well. So we can see that we have our production app, and we have our Postgres database that we need for our production app as well. So that is pretty cool. So let's actually go and check out what that app is. Let me grab the URL again. Oops. We can open up a new tab. And in this tab, we see that we get our hello world. So yeah, this application is certainly not complicated in any way, but I'm just trying to show, how Auto DevOps works, not necessarily a really complicated app. But we see that our app is running. It's got HTTPS turned on, and yeah, it looks good to me. So if we go back, can check out a couple more things, and then we'll wrap up. The last thing that'll happen is some performance testing. So this will actually, do some traffic generation and check response times from browser-based applications, and make sure that your application isn't like super slow, because you want to have a good user experience. So we see that it actually did the testing, and those tests passed, and it kind of dumped out a JSON file and the results, and those uploaded as artifacts. So a lot of these jobs create reports that are uploaded as artifacts, and that's actually how they get slurped into merge requests and pipeline status pages, kind of like how we see here with the license compliance job. Created a report, uploaded it as an artifact, and then that's how we get it here. And the default behavior for those artifacts is that they're stored on the disk of the virtual machine running your GitLab instance, but it is also very easy to hook up, like an object store, an S3 bucket or something like that, to store all that stuff for you. So the last thing I want to show you before we wrap up here is our environments page. There we go. Had a little bit of a brain fart there. So we see that we have on our environments page, we can see our available environments that are up right now, and we see that our DAST environment is actually stopped. So if we actually check the pods in the namespace for our DAST environment on our Kubernetes cluster, that there's actually no resources found. So those pods, those containers have been spun down. But in our production cluster or our production environment, we see which job completed the deploy to production. We see which commit was deployed to production. We see when it happened, and then you can do like live monitoring of it. Right now it's waiting on performance data because Prometheus takes a second. Sweet. It actually filled that in. So we see that our latency kind of spiked and then went down, and our throughput is also decreasing since we're not actually hitting it with traffic anymore. You can get all kinds of response metrics based on whether you're doing it with an AWS ELB, HA proxy, or Nginx. But here we're using Nginx Ingress, and so that's why these are populated.
we should be able to see our system metrics. But it looks like those have not populated. A second, we're getting the numbers, or just the graphs are not drawing for some reason. So anything else I want to show you about the environments page? I think that is about all we really need to do. Yeah, I think that looks good to me. So again, Auto DevOps is a a really powerful tool. It's a great thing to get you up and running whenever you're in the early stages of a project like this. Or it's also really great if you have pre-existing projects that you migrate over to GitLab. It can really help you get up and running with CICD on those projects. Since if you move over to GitLab, you'll probably want to start using GitLab CI just since it's so tightly integrated. You're certainly not bound to use Auto DevOps. You don't have to in any way, but I just think it's a really cool feature, and I wanted to show you, kind of this layer that we built on top of our fully featured CI server. So with that, I will send it back to Raquel and Javier, and thank you very much.
Okay, so that was how you will do all this CI/CD pipeline. How we've seen how we can use it from our code. We can just put it in GitLab EE and then have it deployed in a Kubernetes cluster. So pretty cool demo. So thank you very much for showing that to us. Colin.
Yeah, absolutely. Thank you so much for having me on and letting me talk about GitLab.
Great. So for all of our viewers, so as you can see, it's very easy to just have your GitLab installation in VMware. But in case you have any questions, any comments, any features, any issues, just don't hesitate to check out our community site, where we will answer your questions in community.bitnami.com, and our documentation site in docs.bitnami.com/VMware Marketplace. You can see all of solutions that are in the VMware cloud. So we'll be waiting for you for your input.
Yep. And similarly, if you want to know more about GitLab, just go to about.gitlab.com. And if you want to check out our documentation, it's very fully featured. Anything on gitlab.com, and which is our SaaS version, or the self-managed version, is available at docs.gitlab.com.
Okay, great. So this was our first dev to dev videos, and we'll be back with more. So stay tuned.